In this video, I'm going to do the 4 graphing questions that were included in the handout that I gave today. So these are the first 2 graphing questions, and then I'll do these 2. And then I'm also going to, at the end of the video, I'm going to do the TAN question from the homework in lesson 8. So the TAN question that I know some of you struggled with was this one. So I will do this question with you. Okay, what I should have told you in class that I don't think that I did is when you're given a sinusoidal wave, you're going to be told whether they want you to create a cos equation or a sine equation. So for these first 2 equations, I'd want you to create cos equations. Okay, so let's start with this first one. You always want to figure out what the midline of your graph is, because if we can get the midline, then we can get the amplitude. So the D value is the midline, and remember the formula for midline, it's the max plus the min, and then we're going to divide that number by 2. So the midline would be -4 divided by 2. The middle of this graph is going to be at -2. So these are generally 4-mark questions, and getting the midline would be 1 out of your 4 marks. So right now, if I put the midline in, the middle of my graph is at -2. Okay, from the midline, we want to be able to figure out what the amplitude is. So first, you always figure out your midline. Second, you're always going to figure out your amplitude, which is your A value. So the amplitude of this graph, when I count from the midline, I could count 1, 2, 3 units up, or from the midline to my min, 1, 2, 3 units down. So my amplitude is 3 units. Okay, so right now, what my equation would be, if it was a cos graph, would be 3 cos of x and then -2. I need to get the b value in there, and I need to get the phase shift in there. So I always want to figure out what the period is. So the easiest way to do period is from peak to peak. Now, one of our examples, we can't count peak to peak, so I'll show you how you would count it if you can't go peak to peak. But the period would be from peak to peak, and this would represent the period here, which is 1, 2 units. So because I'm not told if this is in degrees or in radians, I'm going to be assuming that it's in radians. So the period is going to be 2 units, or just 2. Okay, the reason why we need the period is from there we're going to get the b value. So the third thing we always want to get is the b value. Now remember the formula is period is equal to 2 pi divided by b. So b is equal to 2 pi divided by period. So 2 pi divided by the period, and again, the period here is going to be 2 units. The 2's will cancel, which will give me a b, these 2's will cancel, which will give me a period of pi. Now I just want to double check and make sure that my b value is correct. Okay, so now I have this equation here. Y is equal to 3 cosine pi x minus 2. Now we need to figure out the phase shift. So what is important for the phase shift is you're always measuring from the y-axis. If it's a cos graph, you go from the y-axis to the nearest peak, okay? If it was a sine wave, you'd go from the y-axis to the midline, like you'd be on your midline, and you'd go in the direction that would take you to your rise. So if it was a sine graph, I would be going to here. That would be my phase shift. But it's a cos graph. So from my y-axis, I'm going to do my minimum count to my nearest peak. Now in this one, I could go right 1 box or I could go left 1 box. So my phase shift for this example is going to be plus or minus 1. So our C value is plus or minus 1. So what we're going to do is what the equation would be 3 cosine. Now I want to create my b value in front of a bracket. So x plus or minus 1 and then minus 2. This would be the answer, and I'm going to show you how we could punch this into our calculator and verify that we were in fact correct. So on your calculators, take it out and I want you to plug in your y. So I'm going to plug in, so there's my amplitude, cos, there's my b value. I just am plugging in right now x minus 1 and then minus 2. Now remember, unless you are told it's specifically in degree mode, you'd be in radian mode. So make sure you're in radian mode. This is telling me exactly what to change my window to. So my window, my x is going to go from -2 to 8. So change your window from -2 to 8, scale factor of 1. Each hatch mark is going up by 1 unit. My y's, my min is -6, my max is 2, so -6 to 2, scale of 1. Here's the graph, and it looks identical to what I had, to what we were given. So I could also, if I wanted to in y2, type this exact same equation, but I'm going to put a plus here. So 3 cosine of my b value, and then x plus 1, and then minus 2. And it would give me the exact same graph. So this is just a really good way to verify that you are correct. Okay, I will do b, but what I want you to do is pause the video and see if you could get the amplitude, the max, no, sorry, the midline first, then the amplitude, the period, the b value. See if you could do all that. And then unpause and you could verify. So from here, I could visually look at this and see that my d value is going to be 1. My midline is going to be at 1. But it would be a max plus a min. So 2 plus 0 is 2, divided by 2 is 1. Gives me a d value of 1. I'm going to use that to put my midline in. So this is the middle of my graph. And then from here, I'm going to figure out what my amplitude is. So from my midline, it's 2 units going up. So that's 2 units, and this is 2 units. So my amplitude is 2. Okay? So I've got midline in there, and I've got my amplitude. You've got 2 out of 4 marks. We are told that this is a cos graph. So far my equation would be 2 cosine of x plus 1. From here, figure out what the period of the graph is. So the period of the graph, if you could measure peak to peak, measure peak to peak. So from here to here is, how many boxes would that be? So I've got 1, 2, 3, 4 boxes. Each box is worth 1 unit, right? So my period is going to be 4. Now the period is used to get the b value. So period is 2 pi divided by b, or b is 2 pi divided by period. B is 2 pi divided by 4. Pi over 2 is going to be my period. So y is equal to, or sorry, my b value, 2 cosine of pi over 2 x plus 1. Okay, now we need to do the phase shift. Phase shift for a cos graph is from your y-axis to your nearest maximum. So like from here, my c value could go 1 unit to the right, or it could go 1, 2, 3 to the left. You always want to do the minimum phase shift. So from my y-axis, my c would be going 1 to the right. Okay, so c is equal to 1. So the equation would be 2 cosine. Now I'm going to put pi over 2, and then I'm going to do x minus 1, because if I want it to go 1 to the right, that would be an x minus 1. Here's my b value, there's my a value, and then plus 1. That would be your final answer, worth 4 marks. But again, let's graph this. It tells me exactly what window to use. That's the equation that I came up with. So let's check this equation. So I'm in radian mode. I'm going to clear these two. 2 cosine. Now, my b value is a fraction. So I want to put this in its own bracket. So I'm going to do open a bracket. I'm going to do pi divided by 2. And then I'm going to put this in its own bracket, x minus 1. And I'm going to close 2 brackets. So there's my b value, and then here's my phase shift, plus 1. For my window, this window is going to go from minus 4 to 6. So negative 4 to 6, and from negative 1 to 3. The scale going up, it's actually going up by 0.5. And there's something wrong. So what is wrong? Um, oh, my amplitude is wrong. That's how you're going to find you made a mistake. This does not match up. So why is my amplitude wrong? My amplitude, it looks like it's 2 units, but each one is only worth 0.5. So my amplitude is not 2. My amplitude is going to be 1, right? So from 1 to 2, that's 1 unit. And from 1 to 0 here, that's 1 unit. So there is how we would have to. I have had to go through each parameter and be like, which parameter did I get wrong? But I got the amplitude wrong. So this is a 1. This is a 1. This is a 1. And let's change that and see if we get better. There we go. Okay. So again, like this min is at 3, that min is at 3. I could check this max. When x is 1, y is 2. So if I want to check this max, I could go second, calculate a maximum. And I'm going to go left of the max, right of the max. And I just want to check that. So this is 1. When x is 1, y is 2. It's just going up by a scale of 0.5. Okay, so yeah, I made a mistake there. My amplitude is 1 here, not 2 units. All right, let's do the last 2. Hopefully no mistakes will be made. Okay, what I really like about this question is I actually want you to come up with 2 different equations, one for a cos graph, one for a sine graph. I always tell students if they get this one correct, you'll get any sort of question. And the other thing that I really like about this question is they only are showing me a half period. So what are we going to do to get a full period? Okay, so let's do this guy. No matter what, whether it's a sine graph or a cos graph, you always start with the midline. So midline is the max of the graph. So the max is 15. The min of the graph is negative 25. You're going to add the max plus the min, and you're going to divide it by 2. So 15 plus negative 25, divide that by 2, and you're going to get a d value of negative 5 is your midline. Number 2, get the amplitude. So let's first put in our midline at negative 5. And then let's double check. From the midline to the max, it'd be 1, 2, 3, 4 boxes. From the midline to the min, it'd be 1, 2, 3, 4 boxes. But again, each box, I won't make the same mistake as last time. The amplitude's not 4. Each box is worth 5. So 5, 10, 15, 20. 5, 10, 15, 20. The amplitude is 20 here. Okay, so whether it's a sine equation or a cos graph, it is going to have the d value won't change, the a value won't change. The period will also not change. Okay, what you need to realize for this one, you would have done this in your homework in lesson 8, but if you go from a max to a min, or a min to a max, that is half a period. So I'll show you why really quickly that's half a period. Remember that a cos graph would be something like this, and one period on a cos graph is 360 degrees. But if you go from a max to a min, and I just give you this, or let's say for this one it was a min to a max, what did I just give you? I gave you a half period. So you need to realize that this is half a period. So we're going to figure out what one box is worth first. So count how many boxes it takes to get to 60 degrees. They tell me that this is in degrees. We're going to divide that by 2. One box is worth 30 degrees. Okay, now count how many boxes does it take to get from here basically to over here. So a half period is going to be 1, 2, 3, 4, 5, 6 boxes. Each box is worth 30 degrees. So 6 times 30 degrees is 180 degrees, which means if you take that half period and multiply that by 2, the period would be 360 degrees. Now, period is used to get b value. So the formula for b value, it's either 2 pi divided by period, or in this case, it tells you it's in degrees. So 360 divided by period. 360 divided by 360 is 1. So the b value is 1. Okay, the c value varies whether it's a sine graph or a cos graph. So let's do the cos graph first, since that's what we did in our last 2 examples. And we would have an equation of 20 cosine. I need my b value. So b, I'm going to put it in as 1, but I don't need to. Then I'm going to have my phase shift in there for the cos graph and minus 5. So I just need to figure out what the phase shift is. A cos graph, you measure from the y-axis to the maximum. So like you would count to the closest maximum, which would be this one. So the phase shift is going to be 1, 2, 3, 4 boxes. Now, each box is worth 30 degrees. So 30, 60, 90, 120. My C value, if it's a cos graph, it would be 120 degrees. It would be x minus 120 degrees. That's what my equation would be for a cos graph. And we're going to verify after by punching it into our calculator. Now, if it is a sine graph, 20 sine 1, we got to figure out, it's a different phase shift if it's a sine graph. What you have to remember for a sine graph is you measure from the y-axis along the midline. So it would be 1 unit to the right, which is 30 degrees, and then I'm going into my rise, which is what happens with a sine graph. So the C value for a sine graph would be 30 degrees, 1 box to the right. So it would be x minus 30 degrees. Now, both of these, I'm going to punch into y1 and y2 on my calculator. They will give me this exact picture. So I need to be in degree mode. Mode degree. Okay. I need to change my window from minus 120 to 180. And my scale, I'm going up by 30 degrees. I'm going to change my y min minus 25, max of 15, scale factor of 5. Okay, so watch what happens when I type in the first equation. 20 cosine. Now again, I don't need the 1, right? So I could just do x minus 120. Okay, but that's my phase shift, and then minus 5. Gives me this graph. It looks to match up, but let's check by punching in this guy. So let's punch in the sine equation. 20 sine x minus 30 degrees minus 5. And you get the exact same equation. Because again, the phase shift for a cos graph is measured from the y-axis to the peak, the nearest peak. And the phase shift for a sine graph is measured from the y-axis to the midline. So it would be from here to here would be the phase shift for a sine graph. But you get the exact same, 2 different equations can give me the exact same picture. All right, let's do this last one. So again, pause the video, by finding first the d value, then the amplitude. The period is harder to do for this one, so you might want to unpause for the period for this guy. Okay, let's do the d value first, the midline. So the max is 1.5. The min is negative 1.5. So 1.5 plus negative 1.5 will give you 0. 0 divided by 2 is 0. So the midline is at 0. This is the middle of my graph. The A value, again, I'm not going to make the mistake of going 3 units. 3 units. I'm going to say I need to figure out the A value from the midline to the peak would be 1.5. So the A value is 1.5. Normally for period, I really like when we can go peak to peak, but we have an issue. And the issue is you cannot guess like how many degrees that would be. So we can't go peak to peak. So we got to figure out a different way to get the period. So actually before we do period, let's figure out what one box is worth. So count how many boxes it takes to get to 90 degrees and then divide by that many boxes. So to get to 90 degrees, it would be 2 boxes. 90 divided by 2 is 45 degrees. So one box is worth 45 degrees. Okay, if you can't count peak to peak, how else can we get the period? So remember that a sine wave, this would be one full sine wave. This distance from here to here is one full period. So if we are unable to count peak to peak, we have to look at a wave another way. And I'm going to look at it as like a sine wave. And I know that this is 90, right? So I need to figure out the distance from 90 to this. Now, this is 270. What would that box be? Well, I know one box is worth 45. So 270 plus 45 would give me 315. This would be 315. So one period would be the distance between 90 and 315, or 315 minus 90 will give me a period of 225. That's how you would figure out the period most accurately for this question. Now, period is used to get the B value. So B is 2 pi divided by period, but it tells me that this one is in degrees. So it's 360 degrees divided by the period. 360 degrees divided by 40, nope, period is 225. B is equal to 360 divided by 225, 1.6, or math one fraction, 8/5. Now I'm actually going to write it as 1.6 because I'm going to be typing it into my calculator to verify, and I just don't want to create an extra bracket. So just make sure you don't want to test. If it was a multiple choice question, it'd probably be a b value and a fraction, but I'm just going to put 1.6. So b is equal to 1.6. Okay, so right now, here's what my equation would be. I want this one to be a sine graph. So let's look at what that would be if this is a sine graph. Okay, so what was our equation so far? So a 1.5. This one will be a sine graph. And again, I'll tell you why I can't make this a cos graph accurately. My b value is 1.6. And then my midline plus 0. Do I really need the plus 0? No. So far, this is my equation here. Okay, the phase shift is always measured from your y-axis. If it's a sine graph, you count from the y-axis on the midline. Now, I would want to go to the right because remember sine always goes into the rise. So like the original sine graph before phase shift would have been here, and then it went 2 boxes to the right. Each box is worth 45 degrees, so the phase shift is 90 degrees. C is equal to 90 degrees. So the equation would be 1.5 sine, put your b value in, x minus 90 degrees, plus 0, I don't need. The reason why I wouldn't ever ask for the cos equation for this one is because my phase shift would be to the nearest peak, which would be this one here. But again, I don't want to guess that it's not quite negative 90 degrees, right? It would be off. So I would never ask this wave as a cos wave. I'd always ask it as a sine wave. Then to verify, we're going to punch it into our calculator. And that's how we're going to know if we did it correctly. So 1.5 sine, my b value is 1.6, x minus 90, because remember your b value always has to be factored out, close two brackets, plus 0 I don't need. My window is going from minus 90 to 360, so minus 90 to 360. 45 degrees is my scale. Then I'm going from minus 2 to 2, 0.5. So minus 2 to 2, 0.5. Make sure I'm in degree mode. Graph this. Yeah, actually, I'll show you how I could get the phase shift for a cos graph. I need to know what that peak would be. So second, calculate a maximum. That would be the phase shift if it was a cos graph. I go left of the max, right of the max, enter. So it was actually 78 degrees. Like C would be negative, rounded, it would be negative 79 degrees. That's why we can't estimate that, right? So if it was a cos equation, for those of you that want to know, the equation would be 1.5 cosine 1.6. This would be x plus 78.749. Close your brackets, and you would get this exact same picture. Okay, so you need to know those four graphs for your quiz, and then make sure you know how to do from lesson 8, class examples 3, 4, 5 for your quiz. I will do question 6 right now to show you how to do tan, but that will again be for your exam. Okay, let's look at these last two questions. And actually, I'm going to start with B. I find it a little bit easier, and then we'll do A. But once you figure out tan is actually very simple to come up with the equations. So figure out what one box is worth up here. So again, count how many boxes it takes to get to pi, and then divide by that number of boxes. So one box would be worth, so 1, 2, 3, 4, pi divided by 4. That's what one box is worth. Now, in order to figure out the period on a tan graph, it's the distance from here to the next tan wave. So that would represent one period. Now, that's two boxes, right? Each box is pi over 4. So what this period would be pi over 4 times 2. The period would be pi over 2. Okay? If I was to go, for example, to this one, like let's quickly figure out what one box is worth and what the period would be for this one. So one box for this question, 1, 2, 3, 4. Again, it's going to be pi over 4. But the period for this one would be the distance between two tan waves would be your period. So from here to here, that would be 1, 2, 3, 4 boxes. So each box is pi over 4, and there's 4 of them. So the period for this one would be pi. Okay? The reason why we need the period is from there we get the b value. So going back to b, the b value, now remember, if it was a sine graph or a cos graph, the formula would be 2 pi divided by period. It's a tan graph, so the formula or the b value, it's going to be equal to pi divided by period. So b is equal to pi over period. Period was pi over 2. What would happen is if you wanted to punch this into your calculator, you want to put a bracket there, but these pi's would cancel, and this is basically 1 divided by 1/2, or 1 times the reciprocal of this, which is 2. Your b value would be 2. Then, if there's a phase shift, basically what happens is this. If your tan graph goes through 0, 0, there is no phase shift. So this graph, there would not be a phase shift. So the equation for this graph would simply be y is equal to the tan of 2x. That would be your equation, okay? I could verify on a calculator, right? I'd want to type in tan of 2x, and then I'd want to be in radian mode, and I would want to go from, let's go from negative 2 pi to 2 pi. And then my scale is pi over 4. And I'm going to go from negative 7 to 7, and a scale of 1. Right? So it's going through 0, 0, and then it's going 1, 2, 3. It showed me 4 tan waves. 1, 2, sorry, 1, 2, 3.5. 1, 2, 3.5. Okay? Now, let's do the b value for this one. The b value for this one, again, it's a tan graph, so it's no longer 2 pi divided by period. The b value is pi divided by period. Pi divided by the period is pi, so pi divided by pi is 1. So the equation so far would be y is equal to the tan of x, the b value is 1. Now this graph does have a phase shift. The original tan graph goes through 0, 0, right? So the original tan graph goes through 0, 0. Then you count what was the minimum phase shift. So I could go 1 unit to the left, or I could go 1, 2, 3 to the right. The minimum phase shift would be 1 to the left. That makes a C value of negative 1 box, and the box is worth pi over 4. So this equation would be the tan of x, I want it to go to the left, so plus pi over 4. That's what this graph would be. The b value is 1. Again, let's check. Exact same window, right? Except now my equation will be tan of x plus pi over 4. So I'm going to do plus, and then I want to put that pi over 4 just in its own bracket. I don't need to, but I just like doing. So there's my x plus, there's my c value. And now when I graph this, I have a phase shift. It went 1 to the left. Okay? So hopefully that helps.